My name is Matt Woods. I am a technology evangelist here at Amazon Web Services. This basically means that I get to come and talk to smart people, such as yourselves, about cloud computing in general, and answer any questions that you have about Amazon's cloud platform specifically, and then to take all of your feedback, all of your questions, and pass those on to our service and product teams based over in Seattle to help try and continue to innovate and build out our products so that they are meeting the needs of our growing customer base. So I just want to welcome you all to the executive track. We have 3 tracks here today, and in this one we'll be talking a little bit about migration and adoption. We'll be talking and thinking a little bit about how you can think about total cost of ownership and you can optimize costs of your cloud infrastructure. We'll be talking a little bit about security, application security best practices, and how we approach security at Amazon. As Werner said in his keynote, this is really our #1 priority, so we want to make sure that you've got all the information you need in order to be able to start adopting these services within your organization. And then we'll round out, I'm going to come back on after a quick coffee break and talk you through a few use cases that we've seen from customers, a couple of trends that we're seeing, and really hopefully light the light bulb above your head about how some of our customers are using our services to drive innovation for their own customers, be them internal or external. So, as I'm sure most of you are familiar, Amazon Web Services offers a collection of infrastructure building blocks. So these are things such as storage, compute, databases, and a collection of orchestration tools to help you piece these bits and pieces together. We're part of the Amazon family. Amazon itself is probably best known for being a bookstore. In fact, actually, just a quick show of hands. Who here has an Amazon account for buying books and DVDs and Blu-ray? Awesome, everybody. Good. Well, the good news is that you're good to go. That's all you need to get up and running in the cloud. But a question that I get asked quite frequently is, what is a bookstore doing, offering these infrastructure building blocks, these sort of storage and the compute services that we're going to be talking about? And the answer is that Amazon, although we're best known for selling Harry Potter books, we are at heart a technology company. And we're a technology company that happened to go into retail and into e-commerce to start with. And really our structure has 3 main businesses. So the first is our retail business that you're all familiar with. We also offer merchant services to other merchants. And the goal here is to really allow other customers to take advantage of some of our operational experience in running e-commerce platforms. Everything from running the full end-to-end experience for people like Timex and Samsonite, all the way down to the Amazon Marketplace that I'm sure you're familiar with, to allow individual sellers to sell to customers on the Amazon e-commerce platform, all the way down to our fulfillment services. So if you ship individual widgets, you can send them into our distribution centers, and we'll plug those into our fulfillment systems. So those are the 2 areas. The third area is really our developer business, which is Amazon Web Services. What we call web services, other people have come to know as cloud computing. It's this area that I'm sort of going to focus on here. So this Amazon Web Services is a subsidiary, it's part of the Amazon family. We have some characteristics in common with our cousins in retail, such as a requirement and a desire to be completely focused on the customer and to operate at scale and then pass those efficiencies, those economies of scales, savings back onto our customers. So this isn't, excess capacity left over from Christmas or anything like that. This is a completely separate part of the Amazon family. And in fact, the retail side of the business are just another customer to us. They run on exactly the same infrastructure, on exactly the same EC2, on exactly the same S3 as all of our other customers. So that's the sort of background. We, as I say, offer these building blocks that can be provisioned in a utility model. So you can spin up the amount of infrastructure that you need, and then you only pay for as and when you use it. So, I'm sort of a bit like a kid in a candy shop amongst all this stuff. I'm a big fan of technology, and I could, believe me, talk all day about 10 gigabit non-blocking full duplex Ethernet networks. But I'm not going to do that today. Instead, what I'm going to do is I'm going to talk you through how these services can help your business. So I'm going to talk about cloud computing from more of an operational and process orientation rather than the technical side. We have a technical track full of excellent sessions if you want to get that content, but here we're going to focus on how these services can help drive your business and how they can help you reach your business needs going forwards. So our goal when we started thinking about Amazon Web Services and delivering these services, exposing some of our operational skills in running infrastructure, was really based around accelerating this process, right? So the products and the projects that you're working with internally within your own teams really start out with a concept or with an idea. And I'm sorry to tell you, we haven't got an idea service yet, a simple idea service. You have to come up with the concept yourselves. But we want to provide the infrastructure which allows you to move from your concept to your release just as quickly as possible. We want you to accelerate through this process so you can get to market more quickly and you can iterate more quickly. You can make mistakes more quickly, recover from those mistakes, and start to deliver real value to your business. So the problem is that infrastructure, as it's traditionally provisioned in racks, in your own data centers, in colo facilities where you have to go out, spend a whole bunch of money on racking and stacking and powering and cooling and maintaining these servers, acts as real friction to this process. It acts as an inhibitor of this, the acceleration that we want to achieve. You can't get any momentum up because IT traditionally acts as a limiter to this process. So what we saw when we started to think about these sort of service-oriented approaches at Amazon was that our development teams and our infrastructure teams were spending about 70% of their time on what you could consider the sort of undifferentiated heavy lifting tasks of building out new products and new projects. This is work which really didn't add any significant business value. It was just the cost of getting a project off the ground. It was the cost of delivering assets or delivering compute to the customers on the Amazon platform at scale. And we see this mirrored across customers in pretty much every vertical in all the different customer bases that we have. So we have hundreds of thousands of customers, and we see the same thing across these. So this undifferentiated heavy lifting is the problem. It's the inhibitor to the acceleration that you want to achieve in moving from concept to release. And what we saw was when we started working with these infrastructure services, we saw that ratio completely invert. So we saw 70% of time being spent on this undifferentiated work of just racking and stacking servers, no real business differentiation, moving to 70% of that time being spent back on the core competency of the projects and of the teams. So this is a massive recoupment in time that your engineers and your operations team can take back to focus on the real business, the real value in your business, whether that's delivering assets onto the web or whether it's just providing support for your own customers internally and externally. And what we've come to realize is that information technology, IT, it's this enormous industry, a lot of people working in it, and it was specifically designed, the promise of IT was always to add a value to a business, to allow you to deliver on new business opportunities. But what we've seen is that this very same IT that was promised to unleash our imagination and create very innovative new products has actually acted as a significant barrier to getting things off the ground. IT has become very expensive. It's become very inflexible going forward. So when we started working with these infrastructure building blocks, not only did we recoup this time, where our developers more productive, but we could also start using IT instead of it being a limiter on our innovation. It allowed Amazon and allows our customers on the Amazon platform to really use IT for a competitive advantage. IT gets to live up to its claims of being the differentiator for a business. You get to focus in on the core competency of your business rather than worrying about fixing disks and all the rest of it. In addition to that, because we have this elastic utility computing model, right, we think of it a lot like electricity, where with electricity, you want to be able to pull down the amount of electricity that you use and do that in a metered way, rather than having to run your own diesel generators, which you have to fix and put oil in, and they're noisy and smelly and all the rest of it. And again, typically running a diesel generator doesn't provide the value to your business. It's just the cost of getting something done. So we want to move in the same way as companies move from running their own generators to just pulling down power as and when they needed it to use it for whatever they wanted. They left the running and the generation of the power to the experts back at the power station. So we want to enable this sort of utility model of being able to collect and use infrastructure, but deliver it in an on-demand way with utility billing. And what that means is you can pull down as much of that power, as much of that infrastructure as you need, as much storage and compute as you need in order to be able to meet your real business objectives. So we're talking about removing the constraints of statically provisioned infrastructure and allowing you to basically get what you need as and when you need it. And we saw some great examples of that with Jason from Cycle Computing in the keynote this morning. We also want to significantly decrease our time to market. So we want to be able to take our ideas and move them to market as quickly as possible. Again, using these flexible utility models in order to be able to drive the process of development through to the market more quickly. And ultimately, draw focus back onto what really differentiates your business, on what really provides value to your business stakeholders internally and externally. So what we've typically seen is that whilst we have this utility metered billing, and that can certainly draw a lot of customers to start working with cloud computing, that's often the sizzle, right? So that's what gets people interested in cloud computing. But the stake, the thing that keeps them there and keeps them coming back for more and more, is the flexibility and the speed and the agility that it grants to their organization. So developers are able to take their ideas to market, they're able to iterate more quickly and take a more data-centric approach to developing their projects. So we see significantly increased productivity, this 70-30 inversion that we saw. And obviously a reduction in capital expenditure because you no longer have to go out and buy a whole load of computers and disks just in order to find out if your new, let's say, social game is going to be a success on the social networks. So when we got up and running with this about 6 years ago, we had our 6th birthday last month. S3 was launched 6 years ago in March. We certainly thought that because of the massive reduction in capital spend, that this was going to be a very productive environment for startups. But what we've seen since then is a significant adoption across the full spectrum of businesses. So we've seen startup adoption, certainly, and we'll have a great example of that with a customer speaker later on in this session. But we've also seen significant uptick in SMBs and larger enterprises all the way through to government agencies. And that spans pretty much every vertical you can imagine, from social gaming, from companies like Playfish, to life sciences with the work that Eagle Genomics are doing, to government usage such as NASA. And if you want to come and talk to me later, ask me about the NASA Mars rover, a fantastic use case, which I'll be talking about later on in the closing session. So what we've seen is across all of these different sizes, across this spectrum of organizational size, we've seen customers move very, very quickly from asking questions around why do I want to get involved in cloud computing? What benefits can it offer? Moving very quickly to ask, well, now I understand the benefits. How can I start using this? How can I start implementing these services? To moving to being basically fully on board with the platform. So having the right policies, the right processes in place internally in terms of operations in order to be able to have a cloud adoption and migration strategy, and able to start thinking about the full application lifecycle of that application from development and test through to integration testing, through to staging and production releases and all the rest of it, and also being able to quickly adopt new services. And the customer speaker that I'm going to introduce later on has, again, a great use case based around this. So in this session, I really just want to talk about two main things. I'm going to start off by talking a little bit about adoption and migration, and basically tease out some of the best practices that we've seen in dealing with our customers in the successful criteria that we've seen for projects that start to work in the cloud, and hopefully arm you with some of the information that we've gained from all these customers working and adopting and migrating their applications into the cloud, so you can go back into your own businesses and start to lead that charge internally. And then I'll round out with some what you could consider some pro tips for integration. So basically just 5 things, 5 most commonly asked questions that we've seen from our customers when they start working with adopting and migrating applications into the cloud. So let's start with adoption and migration. So the goal here really is to move towards some cloud benefits, right? So there are some key advantages to working in the cloud, and as Werner describes them, building out sophisticated applications. And for me, that sophistication comes from really getting the maximum value of the platform that you're working on. So I'm going to talk to you a little bit about how you can take business line of sight applications or legacy applications and just lift and shift them up onto the cloud. But there is an approach that once you've done that, it's good to start thinking about how you can start to pull down more of the value from the platform. So to start thinking about using elasticity, using scale, and using the sort of automation tools that we have on the platform to help you achieve better benefits and ultimately help you to lower costs. So one of the things I really like about cloud computing in the Amazon platform is the more that you use it, and this is almost unique, I think, for a system of this style, the more that you use it, the more you come to understand how the system works, and the lower your costs are as you build up experience in running the system. So let's take a look at a typical sort of cloud adoption strategy. There's a couple of different elements to this. So this is sort of how I compartmentalize the application landscape that customers are working within. So we have a collection of possibly new applications. So these are greenfield applications that you want to build internally, such as we heard from the Washington Post earlier in the keynote. But you also have a collection of existing applications, so legacy applications, which you may want to move up into the cloud for reasons of reliability or scale or cost savings or anything else. And really, these two different classes of application, and I'm sure you're thinking of the ones within your organization that would be a good fit, have a slightly different approach when it comes to adoption and migration of these cloud services. So new applications, you really have an opportunity from the get-go, like straight out of the gate, to start designing the application to be sophisticated, to have the right levels of automation, to be correctly designed in a service-oriented distributed way, so you can take advantage of the levels of automation, you can take advantage of the levels of elasticity that we have in the cloud to really drive the value there and to be able to control your costs going forward. And we'll have a session on cost optimization later on today. But, as I say, there is another class of application, existing applications, which require a more planned migration. They require a phased migration up into the cloud, and we'll talk a little bit about that. So, for greenfield projects, we talk a lot about cloud-ready architectures. I'm not going to go too deep into the detail here. We've got a lot of white papers and a lot of content and a lot of reference architectures that you can adopt up on our website. The web address is aws.amazon.com/architecture. That's our architecture center to talk about how this works. But the design goals around these greenfield projects, these new projects that you're working on, at pretty much any scale, are really to start to work to design for availability. As Werner talks about, everything fails all of the time. But you can use that failure as a forcing function to build out more highly available systems. If you assume that things will fail, and things will fail in the cloud just like they do in everywhere else, as anyone that's used any type of computer at any time will know. But you can use that to build out as a constraint to start to build out more highly available systems. And again, using sort of elastic, decoupled architecture, using the sort of automation tools we have around Elastic Beanstalk and CloudFormation to help really drive this automated approach. And also, typically, increasingly we're seeing customers take a price-aware approach. So not only are their applications bending and flexing in this elastic utility environment to accommodate changes in demand, but they're also bending and flexing and moving between our different pricing models to achieve the lowest cost for their running application. So these are things that you can only do in this cloud utility environment where there's a collection of different pricing options, and you can use those, as I say, as a forcing function in the same way as you can demand to bend and flex your architecture. So this works really well if you have a completely greenfield application. You can start taking advantage of some of these services really early on. But there's also these existing applications that I talked about that have a more planned migration approach. And this I think of basically in 4 different steps. So we have an assessment phase, an adoption phase, we have a migration phase, and followed up finally by an optimization phase. And so I just wanted to walk you through this to, again, try and tease out some of the best practices we've seen from customers. So the assessment phase is really crucial. And one of the biggest success outcome factors that we see for projects that are starting to migrate up into the cloud. And this is really to select the right service or product within your organization, which will result in a successful migration. Particularly larger enterprises or SMBs that are starting to work and adopt the cloud. This is a really important way so that you pick a service or a project internally which will eventually result in a successful outcome. Now, there are certain things which will make a good fit, but I'm not such a zealot about these things that I don't understand that there are some services which are not a particularly good fit for the cloud. So that Alpha Deck system that has been running for 30 years and hasn't crashed, and the guy that wrote it left 25 years ago, that probably isn't a good fit for cloud computing. But pretty much everything else is. So the first stage of this assessment phase is really to collect and classify your IT assets. So to do an audit around your application and your architecture internally, and basically build up a dependency tree of the services and products that you're running internally. So that might look something like this, right? So a collection of loosely connected or tightly coupled systems in one way or another that might be connected together with a dashboard. And you might have CRM or an authentication service for single sign-on. You might have a collection of content management systems, database search systems, and all the rest of it, along with maybe a web tier on top of that. So once you've built out this dependency tree, once you've got this map and this joined together dependency between your applications, you can start to classify those applications in a number of different ways. So typically we see customers really looking at the security class of their applications. In terms of compliance and regulation, where do these services fit in that context? Where are my compliance requirements around some of these services? Where are my tightest requirements? Where are my loosest requirements? And where do I fit inside that? Now, this isn't to say that Amazon Web Services isn't a good fit for applications which require high levels of regulation and certification and security audits and all those sort of things. It's just that in the initial early adoption phases, when you're treading water, when you're just testing the water, picking something which has the lower level of these requirements is usually a better indicator for success. You're going to find it easier to move forward more quickly. You might think of whether they've been designed internally, whether they've been supplied by a partner or another vendor, whether they've been developed by an external team, how coupled they are internally, but also about the licensing requirements, whether they have licenses which are per seat within the organization, whether they're tied to a MAC address and all these sort of things. And you can basically use this scoring function to identify a good migration target. So something which is typically low impact in terms of security and compliance, which isn't particularly coupled to the rest of your architecture and has the right licensing model around it, which will make it a good fit. Beyond that, it's also important to... oh, we're moving forward. There we go. Sorry. Can I go back a couple of slides? All right, good. So good targets for migration are really things such as web applications, batch processing systems, anything to do with reporting or analytics, development and build systems, they're a really good fit, content management systems, asset management systems, and all these sort of things. These typically have low compliance regulations, and they're typically decoupled from the rest of your architecture, and in some cases, more or less commodity, so you can redeploy them pretty quickly. So beyond that, we move from the assessment phase towards a successful migration. So in a successful migration, it's really important to create the right awareness and enthusiasm within your teams for building out these services. And one way to do that is to start moving through this planned migration process with all of the stakeholders on board from as early a point as possible. So get all of the people that need to have eventual sign-off for this project around the table early on and discuss how this is going to work in real terms. Lay out the benefits, lay out where you see the risks, and work with the security team, work with your CIO, work with your CISO and your CTO to think about how you're going to move through this phased adoption. So when we get into adoption, we start to think of a proof of concept project. So to build experience basically with the AWS platform. And the goal here really is to, once you've selected the project that you're going to migrate, is to really start to think to dive into AWS. So think about spinning up those instances, how you can get up and running quickly, whether that commodity application that you're running is already hosted, whether it's part of the AWS marketplace, all of these sort of things. And really start to map the AWS services in terms of the relational database, in terms of DynamoDB, in terms of CloudFormation, or whatever it is, map those services to the requirements for the application. And critically, don't retool unnecessarily. AWS is a very, very flexible system. You get full root administrative privileges to your instances. It's very flexible, so the goal really is to allow you to bring your existing skills and your existing technical knowledge up onto the platform. So it's not typically, in the proof of concept phase, necessary to retool. We also talk about reference architectures earlier on, and here's the URL for that later on. Here's the URL for that. We also have some white papers that are available to talk you through everything from running SharePoint with Microsoft Licensed Mobility through to developing and deploying a MongoDB application. So these are well worth a read, along with some security and compliance white papers. Beyond that, do your normal due diligence that you would do with any technology project. The cloud is a productivity a set of productivity tools for constrained domains. And just like you're deploying any other technology, it's important to do your own due diligence, to benchmark, and to trust but validate that all of these pieces are moving in the right way. So then we can start to get onto the migration phase. We've picked out a project, we've built out a proof of concept, and now we can start to think of the different aspects of migration. So one aspect is really data migration. So which data sets are we going to move to the cloud? And we typically see customers start to think of the cloud as really a canonical source for collaboration. So moving large data sets which are unwieldy to manage, and unwieldy to collaborate around internally, and start to move some of those up into the cloud. So think of the cloud as a canonical source. This makes synchronization a lot easier, but it also takes away the data maintenance and management problem away from dealing with data sets pretty much of any size. In terms of moving data up into the cloud, we have some data mobility services that can really help here. We heard a little bit about Direct Connect from Adam and Werner. This is a great service for building out a predictable direct connection into the Amazon data centers. This is good if you've got a large amount of data to get up there and you need a 10 gigabit connection, for example, for a short point of time. You can also do multi-part uploads. So if you've got a local pipe that's big enough to get the data up there, you can upload it in parallel. And you can also use the import-export service. So if you can get that stuff onto a USB disk, you can just ship that disk to us, and then we'll plug it in, put it into S3 or EBS for you, and you can run from there. And likewise, we don't want you to be having to be forced to use S3 if it's not meeting your requirements. So if you do have a lot of data in S3 that you want to get out of there, you can send us an empty disk, and then we're pretty good at shipping things around the world, so we'll send it back to you when it's filled up with your data, and you can do whatever you want with it in S3. So again, critically, your own due diligence, and you should act to meet your own requirements and your compliance requirements here. So you should be encrypting the data where necessary. This is part of our shared responsibility model in terms of data security. And the AWS Storage Gateway can definitely help here in terms of data mobility. So you can use on-premise software appliance to back up your data to S3. Once it's on S3, S3 is designed to be tolerant to 2 simultaneous points of failure, delivering 11 nines of data durability. It's really great for disaster recovery situations. After that, once you've migrated the data, you can start to think about application migration. Again, it's important to automate where appropriate here. So you can bring, if you're already virtualized, you can bring your virtual machine images directly up into the Amazon cloud using our VM import service. But other than that, there's sort of 2 approaches that you can take here. You can take the forklift migration approach, where you move the full application basically as a full stack, moving it all at once. And this is good for relatively simple N-tier or 3-tier applications but also for tightly coupled products where you need to move everything all at once. So this is what that forklift migration looks like. So we have our traditional data center over on the left-hand side, and this is our billing service and our billing database, which was identified as a particularly good fit. You can imagine this would have to have high availability and reliability, so we'd be able to deploy this out across availability zones. It might have a large database or a high volume of traffic that we want to be able to scale across. And we can identify the full stack, so the billing service, the application, and the database underneath it. And all we can simply do, as you might imagine, is replace that either through VM import or a collection of application migration and data migration to move it up into the AWS cloud. And then we simply put our existing on-premise traditional data center service on ice for a little while. So we can start to spin down those virtual machines internally and start relying on them on the AWS cloud. There's also a service-oriented migration that you can take. So you can start to think about encapsulated services. So again, here in my sort of business school 101 graph of our traditional data center versus the AWS cloud, we might have a collection of services which have some coupling but are deployed as services. So some process which needs to talk to our billing database and to a search service. Of course, what we can do here is, because they're encapsulated as a service already in a service-oriented way, we can just start to move our search service over into the AWS cloud, wire it up in the right way. You can start to think about how you set the security groups and the customer-controlled firewalls on these, so you can talk about which ports are open. And you can run all of this inside a virtual private cloud where you can also control the networking. So there you can set specific network access controls for inbound and outbound connections. And once you've done that from your ongoing process, you can start to think about migrating the other services. So you can bring across your billing service, set up those security connections and the networking around that, and then connect that up to a process which may stay in-house. And the Amazon Simple Workflow service is a really good tool for starting to orchestrate some of the connections across both traditional data centers and the AWS cloud. That's a very good way of handling the migration while it's in flight on live services. So the goal, obviously, is to minimize service disruption, and the best way to do that is to plan this migration and do it in a methodical, planned way where you spin up, test, and rewire your services as you go through. It's also important to think about how you're going to store and back up any data associated with that. So plan your storage and your automated backup schedule, and also critically start to test that schedule. So start to think less about the mean time between failure and start to think more about how long, the mean time to recovery. Rather than anything else. So because we have this elastic infrastructure, it's really easy to test this stuff. So we've talked about the assessment phase, identifying a project. We've talked about the adoption phase, building out a proof of concept. We've talked a little bit about how once you've got that proof of concept and you've got your feet wet and some comfort with the AWS services, you've got the right mapping to your internal tools, you can start to think about migrating your live services in this forklift or this sort of services-oriented approach. And once you've started to get some services up and running in the cloud, typically that's the point where we see customers start to really work on optimizing it. So using that experience to lower costs, to build out higher levels of availability, and to also build out higher levels of automation around the tools. And this is the point where you can start to think about evaluating and adopting new cloud services. You can start to interleave your existing on-premise infrastructure with the services that have been migrated up into the cloud and start to take advantage of, as Adam described, our very rapid pace of innovation. So this allows customers to start thinking about the Amazon Relational Database Service, which has a lot of tools to help you manage relational database service. So this removes the undifferentiated heavy lifting of running a relational database, and you can start to think about swapping out existing databases, MySQL or Oracle relation databases, with these slightly more advanced tools which take away the operational management of running them either on-premise or in the cloud once you've migrated them up. Similarly, managing message queues with the Simple Queue service or Amazon Simple Workflow. Again, remove that undifferentiated work of just managing message queues. That doesn't really provide any differentiated value to your business. And also with NoSQL. So if you're using non-relational databases, consider about swapping those out for DynamoDB. Again, removing that operational overhead, focusing it back onto your company where you can actually add some value. And typically, this is the point where we start to see customers thinking about making elasticity really a first-class goal, not just as a side effect of working on a utility computing environment, but use that elasticity to drive greater levels of availability, to drive greater levels of scale, and also to decrease costs. As we saw from some of our customer presentations this morning, being able to scale down is just as important in terms of controlling costs as being able to scale up to meet business opportunities as they come along. And we'll have a session later on about optimizing for cost. So utilizing the various reserve capacity and the spot instances that, again, we heard about in the keynote. And to help with that, we can do our part. So where we see greater efficiencies and economies of scale that we can achieve through having more customers and more workloads and more disks and all the rest of it, we can pass those savings back on. And that's something that we're committed to doing and will continue to do going forwards. We've got a very strong history of doing that. We've had 19 price drops since we got started on this without any real competitive pressure to do so. So hopefully that gives you a sort of a run-through of the sort of planned migration approach that we've seen that's delivered successful cloud adoption, that you can take back to your own operation tech teams, your own executive teams within your own organizations to drive some enthusiasm, do your own evangelism within your own company. So with that, we're very excited today to have Lucas with us from XFM. And I would be delighted if Lucas could join us up on stage here to talk a little bit about how XFM have adopted the cloud and some of their workloads. Lucas, thanks a lot.
Thanks, man.
Thanks. There you go.
Can everybody hear me okay in the back? Okay, deep breath, lots of charts. So XFM is a really great sort of application. We're very much a startup company. And what we do is we index music from all over the web and put it together in sort of one very beautiful interface. And what really makes XFM different from, say, the many other music services that are out there is the fact that it's powered by the open web. So what we do is index, say, an MP3 that a blog posts on, say, pitchfork.com. Or whether a band uploads music to SoundCloud or Bandcamp, one of those other great services. We sort of pull that in all together and make it, in a nice package that's simple to share to your friends, stay up with what's going on, what your friends are listening to, what bands are up and coming. And so really what I want to talk to you about today is time. As a startup, time is our most valuable asset. And really what we want to do is eliminate as much time as possible that we're not spending building a better music application and just eliminate it entirely. So let me tell you a little bit about sort of how we got started with AWS. We've all sort of had a shared previous experience with shared hosting and colos and data centers and all the nightmares that come with it, right? How many people have had to go to the colo in the middle of the night to restart a load balancer? Or, is anyone at 111/8? No? So at 111/8, in order to bring in new hardware, you actually have to pay a union fee so you can use the freight elevator. You're not allowed to use the front door. Great. So when we were starting to think about XFM, what we really wanted to do was not deal with any of this mess whatsoever. So out of the gate, we started using EC2, S3, and actually Elastic Load Balancer as well. And because of that, and as Matt said, we have this great value of elasticity. But it seems kind of weird to have this ephemeral, something that was once so structural and tangible to suddenly be the cloud. And we actually use a really excellent Python package called Fabric. If you're not aware with it, you should be. It's really great, and along with Bodo, the Python AWS driver. So we use Fabric to basically drive everything that we do. And another big part that we've started using early on has been the IAM service, Identity Access Management. So what we can do is all of our developers have their own account. They can log into the console whenever they want. There's no more of this, hey, do you have the password exchange going on? And they all have their own keys. So it's great. And really with that, you can also provide a super fine-grained access control to that. So in our case, our CEO, Dan, is the only one who's allowed to actually terminate an instance. So the next time that the main database is killed accidentally, we know exactly who to call. But really, in all of this, we've learned to embrace elasticity and the ephemerality of the cloud. So we have these sort of normal blips when songs go viral, right? Someone starts, what was it a couple weeks ago? Foster the People. So Foster the People put out a new song. Everybody is coming to XFM. There's a little bit of a blip, and then we're sort of back down to normal. But 2 weeks ago, all of a sudden we saw this blip coming, and it wasn't stopping. And literally in 5 minutes, we went from totally normal to twice the traffic in the load balancer. Everything sort of completely maxed out. So all we had to do was run a few scripts, add our new application servers in, and we were back to normal in less than half an hour. This kind of flexibility, it also allows us to try out a lot of different things really quickly that for those of you in the crowd who have a data center, this is going to make you kind of squirm. So we run all types of instances from the micros all the way up to high memory double XLs, for the database. And we like to play around a lot with these types of things, right? So can we make this database server that's kind of expensive run on a smaller instance? What do we have to do? Is that using a RAID 0 configuration? Is that using RAID 10 with EBS? Would the Python application run better with more cores and less RAM? These are all things that we can actually put into practice and try out at basically no cost. So in the case of the RAID 0 configuration, so I was working on this a couple weeks ago and set it all up. It was half the size of the former machine, half the cost. Great. loaded the whole production data set in, ran fantastic, ran better than the larger instance. And so then, a couple of days go by, and the database is now gone. I messed something up. Like I said, so all of our ops is scripted, right? So anything is sort of anything that's done is completely repeatable. So had a small funeral for our dead dev. It was just a dev database, so don't worry about that. So we had a small funeral. Dan terminated the instance, and we fired up a new one, and we were back in 45 minutes. So, and that 45 minutes, 15 minutes or so was probably really the wake portion. And so now we've been taking this a little bit further with moving all of our dev machines into the cloud. So now all of our developers get a micro instance out of the box. And this has been really, really awesome. All of the dev machines look exactly like the production machines, right? So there's no more of this, but I tried it on my laptop and it worked. Get to production, not so much. And on that note, you don't have to deal with this, hey, can you update your laptop with this latest package? Only to have our designers go, I don't know what a package is. So now I can basically just go in and do these things behind the scenes, and no one knows the difference. But moving these things to the cloud, there have been a few downsides, and if you want to write this link down, there's some helpful things in there of how to get people who are less comfortable with the command line a little bit more comfortable. But really out of this came this huge bonus that, now we can share all this stuff. So we can very, very quickly take a prototype that Dan has sort of in his head, show it to a user, show it to our lead investors, show it to our friends and family. Is it something that's actually interesting? When we start out on a new project, we can ship them that first initial product and say, hey, what do you think? And all through that process, we can keep up with them. So this really, out of the box, hands down, even more valuable than eliminating all the time that we were spending on this administration cost, has been incredibly valuable for us. And so lastly, I just want to talk about the managed services. So like we all heard about this morning, the DynamoDB, RDS, this idea of there's these things that exist, you don't have to worry about them. In our case, Cloud Search. So we've been using Cloud Search in production now for about 4 months. Total, we've had, I think, 15 minutes of downtime. If you want to read more about sort of the different tricks that we have, there's a little link you can copy down there. But one of the things that has come up a lot is how do we sort of deal with lock-in, right? There's this magical black box that is just going to work, and do I feel comfortable with that? And the real fact of the matter is you can build Cloud Search with open source technologies, right? It's just a matter of, do you want to invest that time right now while you're a startup, trying to raise a new round, trying to get traction on making Solar run faster? That's something you can do later. And with these new managed services, we're really excited for what's going to come next, right? So a lot of people are probably familiar somewhat with Apache Zookeeper, right? So it's a great way to sort of have a distributed configuration for your cluster, right? So all the machines can be aware, and you can just change it in Zookeeper, and all of your applications magically update, right? Those are the things that get us really, really excited, because this is, again, less time we are spending managing infrastructure, more time building the greatest music web app that we can. And so I hope this was a bit helpful for you all to see sort of how we've been approaching Amazon, which is actually a pretty core part of our strategy. I mean, we have 2 front-end developers and 2 engineers, and we are able to do millions and millions and millions of visitors every month. And so with that, I'll turn it back over to Matt.
Good job. Thanks, man.
Thanks.
Thanks. Great. Thank you very much, Lucas. I think that's a really good example of how you can start to take this phased approach, how you can start to think about moving to development and test, working with more automation, building out on this elastic infrastructure, and then start to weave in these additional managed services at the right point for your organization. So just to finish up, just almost as flashcards, I just wanted to round out with just some pro tips for integration. I want all of you guys to go back into your teams, into your organizations, and basically evangelize about this and be able to basically arm you with the sort of questions that we hear from customers frequently to be able to answer those within your own organization. So this is really just 5 things that we've learned working with customers just really, really quickly. And the first very much is that successful cloud projects, successful cloud adoptions are really motivated by an open process of sharing knowledge. So sharing knowledge between your existing infrastructure teams that may be used to racking and stacking disks, sharing knowledge between that and these sort of more cloud-enabled technologies, and having a very open dialogue with these guys to build some enthusiasm for starting to work in a more elastic way to drive additional innovation and additional business opportunities through this more flexible approach to IT. So to be able to drive successful proof of concepts from their concept right through to the migration. The second, as I said earlier, is to really engage stakeholders. So to get everybody on board as early as possible. That's a really good indicator for success that we see. Do this early and have regular sync or stand-up meetings if you're working in a Scrum environment, and to define your success criteria. So actually have an outcome that you're trying to reach, either an operational target or a business target that you're trying to address. To define that early on and define that and have it agreed across your stakeholders. Thirdly, engage with AWS. This is a self-service platform, and you're not going to get a hard sell from us. The whole point is that you can jump up online and start to work with these services directly. You don't need to talk to me or anybody else. That said, we would love to hear your feedback, and we would love to engage and help you be more successful as an organization. So we have this self-service platform, and typically engagement is driven by the customers. So if you do have specific questions, or you'd like us to take a look at your architecture that you're planning, or you want us to help you evaluate and build out this dependency tree of your applications, by all means get in touch with us. We love to engage with this. We love to help you answer your questions moving forward. We have a fantastic solution architecture team. These guys are a free resource. We can loop them in. They're not the guys that you can call up at 3 o'clock in the morning. We have other people for that. But these guys that can come in, have a 1-2 hour phone call with you, come on site and review your architecture with you. They're a fantastic resource. I thoroughly recommend that you take advantage of them. And also to understand and evaluate the service offering. So understand the difference between ephemeral and block storage. Understand the difference between block storage and object storage. Understand the difference between relational models and NoSQL models. So this helps you build out this map that we talked about in the migration process, to think about where Hadoop or batch processing might fit, and again, to help review the risk and compliance aspects, TCO aspects of your application. And 2, as we heard from Lucas, to proactively adopt new services, to swap out the service that you may be running yourself, to remove that operational overhead, spend time focused back on your organization. Take advantage of the fact that we roll these things out so quickly, and use that as part of your competitive advantage. So when you need new search, just roll it out as and when you need to. So with that, just to review, we talked a little bit about adoption and migration. I hope this has given you a flavor for the sort of process that you can go through when you start to adopt cloud services. And we also rounded out with some pro tips for integration, to start to think about how to engage early and often, and to educate and to come up with those success criteria earlier on. And with that, I'd like to thank you very much for your attention. Thanks for joining us, folks.